we go to this machine, which has little buckets around the outside, so that I can blow air on them and get it spinning to a quite high speed. Something like 5,000 revs a minute. Don't be alarmed by the noise. When we get this 8-pound wheel up to speed, I shall take a pin out there to allow it to flop like this, and then we shall do experiment number 1, which is to search for centrifugal force. If I bring out the gyro to that position, it is free to topple over. I shall need, in fact, a little weight to hold it down. Of course, in any other position, it's all right. It's only when the offset mass comes out there that it weighs over like that. Now, we'll spin this up, and then I'll take the weight off and ask Mr. Coates to catch the gyro as it falls. Now, if you'll come round there and ready to catch it when I lift the weight, next time round it's coming off. He cheated again, says the man in the gallery. Did he really? Yes, he pushed the aluminium back a bit. All right, he'll pull it forward a bit. More than a bit. Pull it forward a lot. The whole of the tower is now well outside the end of the bench. And if you want me to prove it, I'll show you what happens when the wheel is stationary. Again, it doesn't require much catching, you see. It's gentle as a lamb. Now we'll put the pin back in, and we'll see by how much it overbalances. Well, a lot, obviously. How much? That much? Oh, a lot more than that. That much? More than that. That's it. That much. Over 2 kilograms. Out of balance. And if that looks a ridiculous thing to do, I'm going to spin it up again and then turn it upside down. Yep. Sorry. Where am I? Okay. Quite a brute to take upside down. Up to the marks. There we are. When you have seen that, you have seen something you have not seen before. Again, there was the same out of balance, 2 kilograms. These gyros are getting larger, and of course, like electrical machines, as they get larger, they get better. Now, what was very interesting about that experiment, I'm about to show you. I'm going to modify this gyro by putting in a second pivot point. I screw that into there, and then the gyro into the end, and now the gyro has 2 alternative pivots. It can either pivot about there or about there. Okay? Which do you think it will elect to do? Bill? The gyro always knows the answer. Do that. It's never going to stay out there, is it? It'd be stupid to expect it to stay out there. Stupid, was it? Well, what about that one? Let's just have a look at what we've just done. The last thing I did was to take a gyro with a pivot there, another pivot there, and then the wheel. And we found that, of course, it elected for that to come down there like that, and the gyro to stick out there, because by doing so there was no change in the axis of spin of the gyro, no precession necessary. Why then did that work? Because there is a bench overhung. Here was an aluminium plate. The tower was completely outside the end of the table. A pivot there, the wheel there, and the second pivot there. This thing had the ability, if it wished, to do this and still remain with the gyro horizontal. Why did it not make use of the ability to go like that with the tower there and the gyro still horizontal? We shall see. This is the most remarkable experiment, I think, that I've ever done. I'll balance that, first of all, like a seesaw. So there is a balance point. When I take this out here, of course, then the balance point is upset. It should tip down. We know that given the opportunity, it's going to do this if it can, but now we've balanced it, and we've balanced it about its centre of mass. So that if this gyro transfers its mass centre to the pivot, it should stay balanced. The question is, will it? Let those who say I cannot make a body appear lighter than it is come and pull holes in that one.